All right, so Unit 6, or Unit 6, we're not there yet. Unit 2, Day 6, provided notes. Oh, note to self, I need to post these for our online friends. No, you should like it. Yeah, it's you have to write less. We still got to do the work, but you don't have to write as much. In this section, we will solve polynomial equations. Hence the name of the section, Solving Polynomial Equations. Not that all topics aren't important, but this one is a little more so because we use it, and the concepts we come up with, we use them over and over again. A bunch of this we sort of covered in previous days, but we're just going to kind of put it together and make sure we understand it today. Keep the following in mind. We can find the zeros of a polynomial by setting the polynomial equal to 0. Right? That's why they're called zeros, because they make the polynomial equal to 0. F of x equals 0. Zeros are also called roots. Zeros are the x-intercepts of the function. We've said that before as well. Roots, zeros, x-intercepts, all kind of the same thing. I'll tell you later why I say kinda. When solving a polynomial equation, get 0 on one side of the equation. F of x equals 0. That maybe seems obvious, but man, people can really mess things up if they don't get 0 on. They don't move everything to one side. The degree of the polynomial tells you how many zeros you will get, not accounting for repeating zeros. Again, we've said this before as well. But if I have x to the 5th, and that's the highest power, then how many zeros will I have? 5. Now, some of those could be repeating zeros. Some of those could be imaginary zeros. But I'm going to have 5 answers. As long as you know how to count them, there'll be 5 answers. We can write a polynomial in factored form. The degree of the polynomial is the same as the number of factors. But again, be careful about repeated factors or roots. Just exclamation point. Just be careful. So if we had y equals x minus 2 cubed and x plus 4 squared, what degree would that be? 5. So you say, well, there's 2 factors. Like, well, no, there's 3 factors and there's 2 more factors. That would be a 5th degree. If you multiplied it all out, which we would definitely not want to do, but you could see, I think pretty easily, that you'd have an x to the 5th. After that, who knows, but it would be a 5th degree polynomial. So the number of factors is the degree, as long as you're considering the sort of the power of the factor, or how many repeated factors there are. Number 1, if f of x equals factored form, what are the zeros of f? Well, we've done this before, so we set it equal to 0. I'm going to go super slow, show all my work on this one, then we'll speed it up. So we set it equal to 0 because that will tell me the zeros.
That was easy.
And then you set each one of them equal to 0. This is the step that almost none of you show, which is fine because you've done it 100 times and you don't need to show it, usually. But hey, first example, we'll show every conceivable step, and then we'll start skipping around when we can get away with it. So x equals 1, x equals negative 2, and x equals 5. And I suspect the vast majority of you could have answered that without showing any work, and that's okay, because we gave it to you in factored form. All right, number 2, a little bit trickier. What are the zeros of g? What about this x out here by itself?
It's a 0.
It is a 0, so x equals 0 is one of the zeros. What about 3x plus 2?
It's negative 2.
Negative 2/3. So this is one where if you're not sure, take the time to show the extra step of setting it equal to 0. And then subtract the 2, divide by 3, negative 2/3. You don't have to show that, but here's where some people will show their work because it's like, I don't want to mess up the fraction or the sign. So set it equal to 0. Solve for x. What's going on here?
It's a double.
It's a double root. So it is x equals 3. And you don't have to label it a double root.
How would,
but
is there a way you can label without writing double root?
Yeah.
Would a squared on it work? Like in parentheses maybe?
Yeah, because then it would look like 3 squared. So you don't have to label it a double root, but it's probably helpful because what we'll do with them later, you need to know which ones are double root and which ones aren't. So it's probably helpful to label it a double root. Speaking of later, may as well answer this now. What's going to happen at x equals 3 on the graph? It's going to do the bounce thing. So that's why double roots are important. And then that last one, I'll skip the step this time, but in my head I'm setting it equal to 0. Move the 7 over, divide by 2.
Would you just write the 3 twice?
You could write the 3 twice. You could say x equals 3, x equals 3. And so here's where it gets a little bit tricky when I say how many answers does that have? How many roots does that have?
5.
And it kind of depends on...
Unless the 0 is a double.
0 is not a double because it would have been squared. So I would say, I would agree with you, there's 5 zeros there.
But there's only 4.
But the 3
The word we use there is distinct. If we say how many distinct zeros are there? Well, there's 4 different zeros. But mathematically, there's 5 zeros because 1 we're counting twice.
Alright.
Because wouldn't like the last point in the keep the following in mind be following? Like, could you go up for a second? So like that part, whenever you're counting the like degrees,
Yes, it's definitely degree 5.
because the x is its own degree.
Yeah.
Yes.
So then it'd be like 1, 1, 1, 2, 1. Okay.
Right? And even if we multiplied it all out, that first term would be,
X to the power.
well, there's a 2 and a 3, so it'd be 6x to the 5th. After that, I don't want to mess with it. But
Okay.
so the degree is 5. There's 5 answers. There's 4 different answers. Uh-oh, number 3, they didn't factor it for us.
It's not that hard.
So how could we factor that?
Pull out a negative x.
Let's pull out a negative x,
You big brain.
because that will make life a little easier if we take out a negative x. Whoops, and then I almost made the mistake I was about to warn you about.
I just did plus 5.
Yep. If you take out a negative, it switches that last sign to minus 5. Which is good, because then it will factor. So 5 and 1, but a plus 5 and a minus 1. So we set each factor equal to 0. The step that nobody shows, because you don't need to. So sure enough, degree 3, 3 factors, 3 zeros.
Do we need to write the degree if it doesn't ask?
No,
No?
just trying to make all the connections that we possibly can about zeros, roots, x-intercepts, repeated factors, factoring.
And all of those are always going to be the same, right? Degrees, factors, and zeros.
Yes, as long as it's about the repeated thing is what throws us off.
They're what?
It's just the repeated factors is what throws us off.
Yeah.
So this is definitely degree 5. There's 5 answers, but one of them is repeated.
Gotcha.
Number 4, imaginary zeros come in conjugate pairs. This turns out to be great news. So if 4 plus 2i is a 0, then 4 minus 2i must also be a 0. All right, we've done stuff with conjugates before when we multiply. Which of the following is a third degree polynomial with zeros of 3 and minus 5i. Well, third degree means I'm supposed to have 3 answers. It only gave me 2 answers, 3 and negative 5i. So what's the other answer? Plus 5i. So in factored form, that would be x minus 3, x plus 5i, and x minus 5i. But we start looking at our answer choices, and our answer choices aren't factored. We're going to have to multiply this out. And all the answer choices are pretty similar, so it's not like I can just say, well, look at my last terms. 3 times 5 times 5 is 75. But they're all 75. X times x times x is x cubed, but they're all x cubed. So I can't do any process of elimination stuff. We're going to have to multiply this out. So I'm going to FOIL. And then I'll multiply by x minus 3. I suppose you could FOIL x minus 3 and x plus 5i first, but that would be really weird. You should multiply the conjugates first because stuff will go away. So x squared minus 5ix plus 5ix. Again, those are always going to cancel. If you recognize that and don't write them down, that's fine. And then the last one, here's the tricky part. Negative 5 times positive 5 would be negative 25 I squared. Alright, easy part, the 5ix's cancel out.
Wait, why 25 I squared? I squared.
Because
Oh, yeah.
5i times negative 5i.
Yeah.
But that would be positive 25, because I squared is negative 1. So x squared plus 25 times x minus 3. Well, I'm still going to have to FOIL this out, but I can tell that it's going to be negative 75.
Where did you get it to a plus 25i?
I squared is negative 1. So it's negative 25 times negative 1 is plus 25. That is the key, most often missed thing in this section is FOILing out with i's. Remembering that, just being careful of the signs. You know that I squared is negative 1, but can you be careful enough to keep up with it? Alright, x cubed minus 3x squared plus 25x minus 75. And now I'm looking at, man, they got to be super careful here. Minus 3x squared plus 25x minus 75 is C. Number 5, write a 4th degree. So how many answers should a 4th degree polynomial have? 4. Which has roots of 6i and I. Well, they only gave me 2 of the roots.
So you can just put an x on the outside.
But they come in pairs. So negative 6i and negative I are also roots. So x minus 6i, x plus 6i, x minus I, x plus I. Well, if we were okay with i's and factored form, that would be correct. So that's not wrong, but we want it to look like the answer to number 4 looked. So I want you to FOIL out. And the order doesn't matter in terms of getting the right answer, but it does matter in terms of difficulty. So I'd FOIL the 6i stuff terms, and then FOIL the I stuff terms, and then FOIL to put them together. How else are you going to multiply? Well, I guess you could just say you're going to distribute. Oh, because I don't want it factored. I want it to look like I want a polynomial, not in factored form. So I'm going to hit pause, and you see if you can FOIL those out. So there's the first one I did. I showed all the steps, and then I'm like, you know what? This always cancels. So when I get to this one, I'm not going to write out the O and the I of FOIL because I know it will cancel. I squared is -1, so it changes the sign of that. Same thing here. I squared is -1, so that becomes x squared plus 1. And then I need to FOIL that. That's not too bad. X to the 4th plus 37 x squared plus 36. And then I need to have y equals on that, or f of x equals, to make it a function or an equation. All right, turn the page. Square root zeros also come in conjugate pairs. This is sort of related to the quadratic formula. That's the conjugate pair thing, is the plus or minus. And so you've seen this. You may not have said it this way before, but you've seen this whenever you do the quadratic formula. You end up with conjugate pairs, at least if the square root won't simplify. So if 4 plus 2 root 3 is a 0, then 4 minus 2 root 3 is a 0. Number 6, which of the following is a third degree polynomial, meaning should have 3 answers, with zeros of -5 and square root of 3? Well, what's the missing 0 here? Minus square root of 3. So my factors then are x plus 5 or minus 5? Uh-oh. X plus 5. And then if you get these backwards, it won't really matter, right? Because they're both there. So x minus root 3 and x plus root 3. You got to multiply it all out, so the order doesn't matter. But I think there's a wise choice for which two you should multiply first. The last two. So I'm going to hit pause and let you give that a try. So I would multiply those first because they're conjugates, so it should make things easier. If you really wanted to challenge yourself, I suppose you could multiply the first two first, but not recommended. Still get the right answer. Not recommended. All right, lots of good work out there. FOIL, x squared. I'm just curious, are you guys writing out the O and the I of FOIL, or are you like, I know what happens?
We're just doing it.
Not, you know it. You know what happens. Okay, just be careful, because if you hit one that's not a conjugate and you try that, you're going to mess up the problem. So if you know that these are conjugates and you know what's going to happen, then skip it. Just be careful. Don't skip it when you're not supposed to skip it. Let's see, root 3 times root 3?
That's just -3.
Yeah, that's just minus 3. And then times x plus 5.
It equals A.
Apparently it's A. Let's see, first, outside, whoops, cubed,
There you go.
inside, and last. Although now they're out of order, so I better be real careful looking. But I agree with you, it is A.
I was right.
Most of you are right. I think all of you that I saw were right.
You're trying to make us switch your answer. So
Yes, I was.
Nah, I was
Yes, I was.
Change it. After I learned one.
this is what.
There you go.
Number 7, how many real zeros does that thing have? Oh, careful, this real is doing a lot of work here. So let me cover it up.
3.
How many zeros does it have? 3. How many real zeros does it have? Well, we have to solve it. We don't know yet. So there's 3 zeros. How many are real? Let's solve it and find out.
It's so easy.
I mean, it's not hard, but I can't answer it until I solve it.
Yeah, there. That's what it's doing.
So x equals 0. So there's 1. How about x squared plus 16?
That's just
What do I, can I factor that?
yeah. It's x.
How are you going to factor that? You,
Oh no, you can't.
you can't, good.
Oh.
But I can set it equal to 0
I will.
and move it around. X squared equals negative 16. Square root both sides. Put the plus or minus on there.
Plus or minus 4.
For I,
4i.
So that's 1.
Because there's a negative inside.
So it's 3. Because it's plus and minus.
so how many real zeros?
There's 2.
Why?
2. There's 2.
So,
Can't you factor out 4i
Why?
to be 1?
Because I is imaginary.
Yeah, but you can change that to 1.
But it's a
No, that's
Oh, that's I
squared.
power.
I squared. No, I squared negative 1. Come on, know your
that's imaginary. It's not I squared.
I.
Yeah, I squared would not be imaginary. That's what you're saying. That's imaginary. So there's two answers there. They're both imaginary. So let's answer again. How many real zeros are there?
1.
One. Yes. Possible rational roots theorem. This looks really complicated, so I'll read through it. It's a lot easier than it looks. If the polynomial, that ugly thing, has integer coefficients, so this doesn't work with fractions or square roots or weird stuff, but nice normal coefficients, then every rational zero has the form p over q, where p is a factor of a0. A0 was the last term. Q is a factor of an. That was the first term. Here's the shorter way to say this. It's plus or minus factors of last over factors of first. And those are the
Might be plus or minus.
Those are the
first.
plus or minus. Well, as long as you have a plus or minus somewhere, it doesn't matter if it's in the top, bottom, out front. It goes to both. Plus or minus. These are the things that might work. And we'll get to that in a minute. Number 8. Here's our polynomial. What are the possible rational roots of f according to the possible rational roots theorem? So here's how we write it to start with. Plus or minus. And then I'm just going to list out the factors of the last term.
4, 5.
And some people try to list them in order. Other people will list them as pairs, like 4 and 5, because they kind of come in pairs.
120.
I like to list them in order because it makes more sense to me. But you're right, you do think of them in pairs.
10. No.
So here's how you can do both at the same time. There's 1 and 20.
Oh.
What's another pair?
2 and 10.
2 and 10.
5, 4. 4 and 5.
Yeah, either way. And then we've kind of met in the middle, so we're out of factors of 20. How about factors of 4?
1 and 4 and then 2.
1 and 4 and then 2. 2 and 2, but I don't want to list it twice. Now, I'm not going to require you to list out every possibility with the plus or minus. So we can put a plus or minus out front and still have that cover everybody. But now I need to come up with every possible combination of top number and bottom number.
Great.
Oh.
So over 1, that's the easy one, right?
Yeah.
1, 2, 4, 5, 10, 20. That was the easy one. Over 2, that's pretty easy as well, but we start getting duplicates. So be careful, don't list the duplicates. So 1 over 2. 2 over 2.
1, so it's already there.
We already have 2 over 2. 4 over 2.
It's 2, it's already there.
5 over 2.
5 over 2.
Yeah, we don't have 5 over 2. 10 over 2.
That's just like.
Got that. 20 over 2.
10 is already there.
Already got that. So we only really got 2 new ones out of the over 2s. And now we need to do over 4s. And the same thing, watch out for duplicates. 1/4 we're good. 2 over 4. It's like how quickly can you reduce fractions here? We got 2 over 4. 4 over 4 we have. 5 over 4 we don't have. 10 over 4.
That's 5 over 2.
That's 5 over 2. 20 over 4 is 5.
Yeah.
So how many, because this shows up as a question in the worksheet and on the test, how many different possible rational roots are there?
20, right? Because it's plus and minus.
20.
Because you double it, use the plus and minus.
It's 20 because of the plus or minus. And that's one way we ask the question on the worksheet and test, is how many possible roots are there? Yes, sir?
Wait, did you get 1, 2, and 4 on the bottom?
Those are factors of the bottom, or excuse me, factors of the first
Oh, okay.
go in the bottom, factors of the last go in the top. And then don't forget the plus or minus. So you don't have to write out the plus or minus because that gets tedious, but don't forget to basically double your number of answers based on the plus or minus. All right, now here's the part you may not like, because this comes from the land before calculators.
Oh, no.
I know that predates you by a long time.
So that
It doesn't predate me by much, so, but it does predate me. We had calculators when I was in high school, just so you know.
Just
That's right.
you just couldn't use them.
We just, well, it's like now. You could use them for some things and not for others.
They were about the size of this.
No, they were.
Anything other than math.
They were the size that you have. They couldn't do as much as yours do, but they were the same size. Remember, they were blue. TI-80. I don't remember what the number was. Anyway, we can use synthetic division to test possible rational roots and help us solve for the zeros. So I can't factor that. I could put it in the calculator and look at the graph to find the roots. But in the time before calculators, we couldn't do that. And it's like, well, how do I know what works and what doesn't? Well, I could try. I at least know what to guess. It's a game of guess and check, but I'm not just guessing random numbers. I'm going to guess factors of last over factors of first. And it's real nice when the first is 1, because I don't have 20 numbers to check on this one. Right? When we make you play guess and check, we're not going to give you one like number 8 where there's 20 things to check. And there was only, on number 8, there were 4 answers. So at most, 4 of these 20 are right. We're not going to do that to you. Here there's 8 possibilities. Still doesn't sound good. I'll grant you that.
18.
We'll use synthetic division.
Oh, wait. Wait, how? What?
Because if I synthetic divide and it works, how will I know it works? What am I looking for?
If it's 0.
The remainder is 0.
But that's.
So I have 8 choices to pick from.
Oh.
So you have to do all of them?
I don't have to do all of them. I do have to do them until I get an answer.
Do number 1.
All right, let's try 1. Copy down the 1. Multiply, add, multiply, add, multiply, add. Why do you say no?
Because it's not
Negative, negative.
So that's a no. All right.
So maybe it's a 3.
So what do you want to try next? 1 didn't work.
3.
Can I veto your guess of 3?
Yes.
Yes.
Yeah.
It's not too easy.
It's
What
6.
else would you like to try?
6. It's 2.
Try the easier numbers first, because they're easier to deal with.
Is it, it's not.
Well, I heard someone say -1, or we'll pretend I heard someone say -1.
Isn't it,
But you guys are illustrating what can sometimes happen on these. If you guess wrong, you can guess wrong for a while till you finally get one that works.
oh, that means if we had the one with 20 of them, that would suck.
That's why I said I'm not going to give you one that has 20 of them, because
Huh. Wait, it would be a negative.
it would be terrible. Ah, we found one that worked.
Yay.
Yay.
What a good guess by me.
Huh?
Ah, yes.
How did I know it worked? What am I looking at?
Because we
Remainder 0. So we're good. So x equals -1 is one of my answers. Find all the roots. Okay, now you're disappointed because you're thinking I got to keep guessing until I find the other two. But
negatives? Or is that the only one?
so we started with x cubed. Well, let's look at this one. We divided and got one that works. So that means that these depressed coefficients,
Or depressed.
kind of our new coefficients we can work with.
So then we plug it into this one.
Well, if I wanted to keep testing, I could test on the depressed ones. Yes, that's true.
They're depressed.
But I've got one that'll factor, so I don't have to guess anymore.
So,
But so you just do the -1 again.
I'm not guessing anymore because I can factor that. Once you get it down to a quadratic, there's no more guessing because you can always solve a quadratic. You can't always factor a quadratic, but you can always solve a quadratic. X equals 2, x equals -3. We knew from the get-go that this would have 3 answers, and we found it. Remember, this is from the land before calculators.
But that doesn't mean there isn't a way.
On a calculator, you would probably just graph this and look for the x-intercepts. This graph is going to have an x-intercept at -1, at 2, and at -3. So you could use your calculator to like check. Whoops, something like that. But this was going to be on the no calculator part of the test.
So we'll have a calculator as a part of this test?
Actually, you won't have a calculator for any of this test, so it won't matter. But if you're working at home and you want to check, I don't mind that. Plug it in your picture and plug it in the calculator, and it should look like that. All right, number 10. This is the last one because the rest of the notes are for Friday. Find all the roots. How many roots should there be?
4.
4 roots.
But that means there's going to be a lot.
Possible rational roots. Oh, I heard that. That was a... So, factors of last, factors of first.
Whoa.
So how many total roots are there?
Ooh.
Or how many... Well, there's 4 total roots. How many possible roots are there?
There's
4.
There's 4 because of the plus or minus.
It's
So
a trick
it's just-
question.
Be careful though, because we had this issue earlier with something else. When it comes to counting roots, you have to be careful about double roots. So it's not a guarantee that all 4 of these are roots because some of them might be double roots,
There's
or
roots.
even triple roots or quadruple roots. So let's just guess and see what we get. Now you're right. I'm only guessing out of 4, and there's 4 answers, so we should hopefully. Let's see. What do you want to guess first?
Let's do -1.
First number I heard was 1.
Let's do negative. It's going to be because it's the same number of negatives in the other one, so it needs to be a negative.
Let's see. 1 times 1.
Okay, Crystal, come on. Really?
Crystal already did it, so she knew it would work.
Dang, you really got
So
it.
now that you do 1,
You really
So let's kind of make a note of this. X equals 1 works. We don't want to lose sight of that. And now we can use the
the painful.
depressed coefficients.
X3
I'm still having to guess because I've got x cubed.
minus 2x squared minus
Which one are you trying? What do we want to try next?
plus 2.
You want to try -1? Okay.
Huh?
I don't think it's -1.
It's not.
Wait,
It's not work.
I don't know. You said to try it. Let's see.
See, I was right.
It did work.
Okay.
See?
Yay.
I'm smart. Wow. Come on.
Good
Crystal.
news. Oh, even better news.
That we got them all.
Well, I don't have them all because I'm supposed to have 4 of them.
But now you can
We got to do it
factor.
again.
But now I can factor. I mean, you don't have to factor. Like if you're
You can do it
factoring
again.
that's broken down and you can't factor that, then there's other problems. But you could keep guessing and use those coefficients.
Does plus or minus 2?
But come on, we know how to factor that.
We do.
It's, yeah.
Well, like I said, if you don't know how to factor it, then keep guessing.
Or go back to algebra.
Well, I can't be that snarky with my bosses in the room, so. X minus 2, x minus 1, so x equals 2,
So that means there's
x equals 1.
2
So then there's one.
That means
Ah,
there's
so there was a double root.
There's a
X1 is double root.
X equals 1 was a double root. So when we get to graphing them, that'll be a bouncer situation.
So the answer would be x equals 1.
So if you end up kind of finding them as sort of in this order and you write it twice, that's fine. If you want to identify x equals 1 as a double root, that's okay. It's probably helpful because later it's going to matter more that it's a double root. All right, we're done today. The worksheet 6 is today's assignment. Remember, tomorrow
So we don't do this.